It says hi in there. Well, hi. Well, still, it's, now, hi, now. So, hi, thank you for coming to my presentation. And I know there's an interesting talk in the other stage, so I appreciate that you guys are here listening to me. So, I want to start with a small question. So, how many of you are JavaScript developers? Can you please raise your hand? People here, yeah, exactly. So, probably this tells you something. Undefined is not a function. Sounds familiar? No, like that, yeah. You can see it better there, right? Yeah. That sounds familiar to me. What about this? Yeah. That's pretty much the same thing, right? Just a function undefined that you're calling there, but it's over an object instead of calling the function directly. Or maybe if you're consuming APIs, if that sounds familiar for you, this number. And you know what all of these have in common? They are representing errors. And you think that your code is great, that you only think about the success scenario, like everything is going to go well, but that's your face when you encounter an unexpected error. Am I right? So, but before putting that face and facing unexpected error, you have to be aware of something, which is that shit happens and it smiles at you, because we are not prepared to handle errors in our applications usually. You are always modeling your app or your API or whatever, just focusing on in the success scenario. So once you have it ready, you don't think about what can go wrong. So it's very important in all applications to handle errors and to force yourself to handle errors. This is a super important topic in my opinion, so that's why I want to share with you how can we model errors in Now CLI. So we are going to spend like the following 20 minutes speaking about why it's important, error handling, how can we model errors to give proper messages to our users, messages that they can understand and they can fix. And for this, we are going to follow a real example of Now CLI. My name is Javi Velasco. That's my beautiful dog, and that is my Twitter handle. In case you want to catch it, do it now because you are not going to see it again in the entire presentation. I work for this company called ZEIT. Probably many of you already know it. And inside, we have many microservices and many APIs that are publicly available for you or users. And all of those APIs can be considered as independent products. That means that we have to model every API with proper errors, with a nice spec, and of course a good documentation, so you can be aware of what are the possible responses of those APIs, including all possible errors. But also, we have some applications and services that are communicating those services between each other. And that means that there is a lot of complexity aggregated in some entry points where we have to deal in some way to show properly what was wrong and how can we act about it. And the best example of this is Now CLI. For those that don't know about it, Now CLI it allows you basically to take your JavaScript or Docker file-powered applications and put it in the cloud with this speed and reliability. Any directory that contains a package JSON or a Docker file can be deployed just with one command, so you would get a unique URL. But at some point, you might want to change that URL to a custom URL. We call that feature Now Alias. So let me show you an example of Now Alias. The problem with this process is that we have to communicate many APIs. First of all, we have to check if the domain exists. We have to check if you have permissions over the domain. We have to check if there is a certificate. We have to consume maybe the availability API to offer you to buy the domain in case you don't have it. And we also have to tell you the price of that domain. So there are many things that can go wrong in each of those APIs, and this is the aggregation of all of those APIs. But basically what we have in the end is a function, very simple, just like that. We have a create alias function that receives 4 parameters. The alias you want to create, the deployment URL, a user ID, and maybe a team ID. Those parameters are going to be provided by you from the CLI, except from the user ID and the team ID that we can grab from the current context. And in case the function performs successfully, it is going to return a descriptor object for an alias. But in case it doesn't go well, what can we do about it? So of course what you can do is just to wrap that function in a try-catch block, get any error, and just tell you, hey, there was something that was wrong with your alias, so it didn't work. But that would be terrible if we do that, because maybe the only problem is that you don't have a certificate. Just for the record, we do handle creating the certificate automatically for you in case you don't have it. But for the sake of this example, let's just assume that you have to create it manually. So it's not cool if we just tell you, hey, something went wrong. What you want to know is what exactly went wrong, so you can act in consequence. In this case, it would be just creating a certificate, right? So the question here is, why don't we handle errors? And I have a few reasons why we don't care too much about error handling. Some of them, at least, can be applied to myself. The first of those is the lack of context. So an error is going to happen always in a place in your code when you probably don't have the context you need to be explicit about what went wrong. Like, for example, in Now CLI, we have a current context. You might be operating on your name or on your team's name. So then, always when there's an error, we want to tell the user what context you are operating in. And probably that information is going to be missing in the exact place where the error happens. So we need a way to gather that information to show a meaningful error. So let me illustrate this to make it more clear. So we have a user, and you are going to call this function createAlias. CreateAlias is going to do a few things. First of all, it's going to fetch a user, and then it's going to fetch a domain. And assuming those two went good, it's going to create an alias. It's going to call this request createAlias function, which is the one that is going to perform the request. So that function maybe validates the data, and then it performs the request. And that request is going to hit the server. But you know what happened? That the server can return an error because you're missing a certificate, for example, or for whatever other reason. But anyway, it's going to fail. It's going to give you an error code, maybe some payload. We will speak later about this. But then when that error is returned, the place when you are noticing the error is in the perform request function. The perform request function doesn't know anything about aliases or error codes or whatever. It just does a request and it fails. Something should happen. So that's what I mean by lack of context, because we can't stop the execution there, print the message, and finish the execution. We can't do that. First of all, because you can't reuse that function in that scenario, and also because you don't have the context. So that's what I mean by lack of context. There is another reason, which is the unknown error space. Problem with the unknown error space is that we don't know what are the errors that a function can throw in JavaScript. Neither we know, when we are performing the request, how the server is going to react. Because maybe it returns an error, but you don't know the error because it's not documented, because it was very recently added and you never adapted your API, or they are not using semantic versioning, or you are not using semantic versioning, or whatever. The case is that you are getting an error code that you don't know at all. So problem is that you can't do anything about that. You can only go to the documentation and read all the possible error cases and model every error case accordingly. But also, our own functions are going to return errors or throw errors or whatever. So the thing is that when you add a new error, like for example, let's say that the request create alias now can return domain permissions error, for example, the consumer function, which in this case is create alias, should be aware of that. So the problem is that we don't know the error space, and we are always mutating our code, adding new exceptions, adding new cases, throwing new exceptions, and we have to update that everywhere. And in the case of errors, we don't have a way to model that properly and to get insights to act accordingly. So that's why we have a lack of context and unknown error space. Those are two of the most important reasons, in my opinion, why we usually don't model errors. But those have solutions, actually. The problem is that we are very lazy. Because let's be honest, you start working in a new application or a new program, a web page, whatever. And once you have it ready, you do a demo, you cross your fingers, expect everything is going to go well. Everything goes well, and you get your greetings like, very cool job. And you are like, yeah, I hope it doesn't fail. And leave the shit to somebody else. But we are good developers, we try to be professional, and we should try to figure out the nice error handling all the time and let the users know what's going on. Also, you're gonna make friends, you know, because if you have a support guy in your team, he's gonna massively thank you for not having all of those emails from people asking what the fuck was wrong with your product. So we are going to see a couple of techniques that we have in place now in Now CLI to help us figure out what can go wrong with every function call. So the first question you have to ask yourself is, where should we control errors? And if you let me ask you this same thing in other words, I can say, what is the consumer entry point? Because the place where you want to control errors is where those errors are meaningful. And the most important place where to put those errors is in the entry point. So, yeah. In the case of our API, I said before we have two different products. In the case of Alias, we have our APIs that are consuming and also the Now CLI. We are going to focus first on the API. So how can we model errors in the API? We have a function that is the entry of our API, which is going to be just an asynchronous function, an endpoint, as you can see there, that receives a request, a response. Then that function is going to call some actions, databases, fetching data, or whatever. But something can go wrong there, so that function is going to throw. And this is the entry point to our API. So what you can do is just to have like a wrapper function, like a factory function that is going to get that endpoint and return a new function that takes the same arguments. So you can call that function, and in case something happens, like it's throwing any kind of exception, you just catch it, send a 500, and that's all. But this is essentially the same thing that I did before in Now CLI, and I said it was very bad, because you have to get a way to know what is exactly what went wrong. So what you can do is to have like an expected error class that extends from error, because this way, extending from error prototype, you're going to get all the benefits from it. Like you have the call stack and everything. But you are going to add a very specific contract there, telling what is the code, the HTTP status, and the payload. So this way later, when you are modeling a specific domain error, you can say, for example, our misinsert error is going to extend from expected error. And in the constructor, we are going to pass only a domain. Then it's going to call supper, and it's going to say, this error is going to have the code misinsert, HTTP status 400, and this specific payload, and a helper message. Then you consume that error by throwing a new misinsert error. That should be an object, actually. It's fine. And later, in the handle errors function, you can just pattern match that error. So you say, if the error is an instance of an expected error, you don't have to be exhaustive, only use that expected error. You can be sure that there is going to be an expected HTTP status and a payload. So the API can respond accordingly. That is going to bring many benefits. Like, first of all of our errors are going to be homogeneous. They are going to share the same structure. Secondly, we don't need to drag errors around. We can just throw anywhere. The error is going to scale up in our function layers until the entry point, and then we respond accordingly. So we are going to have only 500 errors when the error is completely unexpected. And also we can use the prototype to do pattern matching, and we can have an index with all of the errors listed there. that is pretty handy, especially when it comes to documenting our APIs. So what does this mean for our Now CLI, for our consumer? It means that, going back to this diagram, we are consuming an API that we know now that is going to respond always with error codes. So we can go to the documentation, check what are the error codes, and we can model each of those accordingly. But still, the problem is that in perform requests, we don't have the context to react accordingly. So the only thing that we can do there is just to throw a generic API error. But since we know that every error is going to share the same payload, we can model that error so it has a code, payload, and everything. So we can just throw it away, and every consumer function that knows that there is an API call underneath can catch that error and show something a little bit more meaningful. Like, for example, our create alias function can just catch the error, check if it's an instance of an API error, and then it can just output the error message that is coming from that API error. So in this case, it's a little bit better. It's not way better, but it's a little bit better because we are telling the error that come from the API instead of saying something went wrong and we can do nothing about it. So still the problem is that the semantics are different. What we want to say there is there's a missing certificate, you have to create a new certificate before doing the alias, but we are saying that there was just an API error. So the next step is to recall what is the actual context. So the function request create alias is the one that is performing the request, and that is the point where the code is failing. So what we can do is to model, to catch that error there, and then model the error accordingly, because we do have the context enough there to make a more meaningful error. So in this example here, what you can see is part of the implementation of request create alias. As you can see in the arguments, you are getting the alias and the deployment URL just as in the entry point. But since you were fetching the user, you were fetching more information, you can pass the information in the function signature. So when you perform the request, you can wrap a try-catch block. And then when you catch an error that is an instance API error, you can refine a little bit more that matching to check what is the error code that the API is returning. So in case the error code is a cert missing, then you can create a new, more meaningful error with a very specific payload, and you can even index that error in the whole Now CLI. That error, in this particular case, is going to include the context that we can get from the same function, the domain error, the domain itself. We don't have the domain, it's coming from the API, the deployment URL, and the alias. So then we get this error, we throw it away, and we expect somebody to catch it. And the most immediate place where we can get it is in the consumer function of create alias. Then when we pattern match the error again, we can be more specific. Because now we know that it could be an API error or a specific API error, which is a cert missing for alias. I think that the name is explanatory, right? So you can react accordingly, and most importantly, you can use the same error payload to tell the right message. Like, for example, you can say there is no cert for error that domain, because you know that the domain is coming in the payload. And you can say that we can't alias the given alias, and you can even recommend the user what to do about it. Like, you can create a search by running whatever. But if it's not that error, you can just say there was an API error, if it was an API error, or then worst case scenario, I'm sorry, something went wrong. So that's about the lack of context. But then how can we handle the unknown error space? If you first focus on the server, there's nothing that you can do about it. Just go to the API spec, to the documentation, check every error, and hope that all of the actual errors are documented properly. So if it throws something that you don't know, you can't really do anything. does something unexpected happen. But also there is a different context for this unknown error space, which is when you add new errors to your internal functions, to functions that are part of your code base. Like, for example, imagine that this perform request is going to return an error, and it is a new error that is called domain permission error. So when that happens, you have to update every consumer. And the question that you have to ask yourself in this case is, what are the errors that a function can throw? And the response to that question is that we don't know. We don't know because there is no distinction between what is an expected error and an unexpected error. We just throw it away and hope somebody to catch it. That led us to the next question, which is, what is an error? An error is actually the result of an operation. We are very used to do like a adding operation, and we expect the result to be the addition of those values. But then when something can go wrong, we are not used to say that the return value can be an error. We just expect the function to throw. So the question is, does it make sense to return errors rather than throwing? I believe it might make sense in many, many scenarios. So for this purpose, we can just write a wrapper for a function that is, we are going to call it return instead of throwing. And that wrapper is going to receive the function that we are going to call and the known errors that we know that that function can throw. So to use this function, we can go back to our request create areas function. So we are going to say call perform request with this endpoint and these options, but in case there is an API error, return the error rather than throwing. This way we can pattern match the error and then inspect the code. And in case it is a cert missing for alias error, certificate missing error, instead of throwing away the error, we are going to return it. So now we basically have kind of the same thing, but we are returning rather than throwing. So the question changed. Now we are like, what are the errors that a function can return? But the answer is still that we don't know what are the errors that the function can throw. Because JavaScript, we don't know what can be returned from a function. But this time, we have tools that can help us figure out what are the possible returning values of a function. Static typing to the rescue. We can use Flow, we can use TypeScript, or you can switch to another language. Who knows? But anyway, if you're using TypeScript, this is very, very revealing, because you can now type your functions. And you can go to this create areas function, and you can say, it's a function that is going to receive a string, which is the alias for strings. Alias, deployment URL, user ID, and team ID. And it is going to return a promise that would resolve into an alias descriptor object or a cert missing for alias error. So then, suddenly you say, well, I'm going to add a new error. You are forced to add that error in the signature. And then when you consume the function, you say, call this operation create alias, pass these string parameters, and then pattern match the result against the instance of a cert missing for alias error. Then you get a false result, and you say, okay, so it went successfully, I'm going to print the alias. But if you typed your stuff and that function it's possible to return into a different error, you are going to get a flow error. And it's going to tell you that you are not, that result object doesn't necessarily have that alias field, because it could be a domain permission error. So that's very helpful. So just to recap, first thing you have to do is to get to know the error space, and then you have to make a separation between what is unexpected and unexpected errors. Then you can return expected error rather than throwing, because this way you can use static typing systems to force you to handle every error and to type every possible result of an operation. This way we can build richer error that can go and scale up in the function call stack and adding up new information. So finally, in the top level, you can inspect the aggregation of errors that you have, so you know every possible error that the function can return by aggregating different functions that are already typed. And also you are going to have a very complete error that is enough to show enough information to the user to provide meaningful and rich messages. And one more thing. Well, no. Thank you, that's it.
Let's give it up for Javier. All right, we have the one question here.
How do we? Well.
Are you using those specific error paths for any kind of analytics to find possible places to improve the API?
Yeah, that is a very good point. Actually, yes, we are tracking. I mean, the good part is that since you have a single entry point there and you have a place where you are recovering every possible error, and since you know the structure of that errors, that is a very good point because it's super easy to report those errors in an analytic service. We are using one called Librato. And you can tell there not only the error, but the payload of the error. And later in the same tool, you can filter by error codes. So you can have very easily, and we do have very easily analytics in each endpoint of what are the most common errors. Yeah, that's very useful.
All right, let's give Javier a round of applause.
Thank you, guys.
Thank you very much.